Hello students, our lecture 4 is on the topic discrete and continuous bivariate random variables. Under lecture 3 we have worked out some questions related to discrete and continuous bivariate random variables. So we will continue with the questions on continuous bivariate random variables. Question is the joint probability density function of the random variables x and y is given by fxy of x comma y is a into e power minus of 2x plus 3y for x greater than or equal to 0, y greater than or equal to 0 and defined as 0 elsewhere, means for x less than 0, y less than 0, fxy of x comma y is 0. Find the constant a, find the marginal probability density function of x and y. That means fx of x and fy of y are x and y independent. Find these probabilities: probability that x will be greater than half, probability that y will be less than 1, probability that x will be less than 1 and y is greater than half, probability that x will be greater than y. Now from the definition it is clear that x and y are continuous bivariate random variables as x and y value varies from 0 minus infinity to plus infinity. For x greater than or equal to 0 to infinity, y greater than or equal to 0 to infinity, fxy, the joint probability density function fxy of x comma y is defined as a into e power minus of 2x plus 3y. For x less than 0, y less than 0, fxy of x comma y is defined as 0. Now find the value of this constant a. Since fxy of x comma y is the joint probability density function, it will satisfy two conditions. One is this fxy of x comma y will be greater than or equal to 0. Another one is the double integral of this fxy of x comma y with respect to x and y from minus infinity to plus infinity, that must be equal to 1. So we shall use that condition, double integral is equal to 1. But here this integrand fxy of x comma y will be a into e power minus of 2x plus 3y for x greater than or equal to 0 and for y greater than or equal to 0. That means, and it is 0 for elsewhere, means if x and y are negative, this integrand will be 0. So in this integral from minus infinity to plus infinity means even negative values are considered. So you consider it from 0 to infinity so that negative values are ignored. And the reason is for negative x and y values the integrand will be 0, so the double integral will be 0. So ignore it, consider positive non-negative values of x and y. So inner integral we have taken it with respect to x, outer integral with respect to y. We can also take it as inner integral with respect to y and outer integral with respect to x. Now inner integral with respect to x is from 0 to infinity, outer integral with respect to y, so y is also from 0 to infinity. Double integral is from 0 to infinity and the integrand fxy of x comma y is a into e power minus of 2x plus 3y. Keep that a outside the double integral sign. Integrand will be e power minus 2 of 2x plus 3y dx dy. Now first we will calculate the inner integral with respect to x. So this e power minus 3y which does not contain x can be kept outside that integral sign. Integrate this e power minus 2x with respect to x, which is e power minus 2x by the coefficient minus 2. Difference at the upper limit infinity, lower limit 0 dy. So a into integral 0 to infinity e power minus 3y. Now calculate the difference. Put x as infinity, e power minus infinity will be 0. So 0 by minus 2 is 0. Put x as 0, e power 0 is 1. So 1 by minus half. So the difference will be 0 minus of minus half, 0 plus half dy. half can be kept outside the integral as 2 into e power minus 2x for x greater than or equal to 0. Fy of y is calculated as 3 into e power minus 3y for y greater than or equal to 0. If you multiply these two marginal probability density function fx of x into fy of y, then the product will be 2 into e power minus 2x into 3 into e power minus 3y for x greater than or equal to 0, y greater than or equal to 0. Multiplication gives 2 into 3 means 6. Then e power minus 2x into e power minus 3y means e power minus of 2x plus 3y. So it is 6 into e power minus of 2x plus 3y for x greater than or equal to 0, less than or equal to y greater than or equal to 0. For x less than 0 or for y less than 0, fx of x is 0 or fy of y is 0. So the product will be 0. Now you can see the definition of fxy of x comma y. It is same as a into a is 6 into e power minus of 2x plus 3y for x greater than or equal to 0, y greater than or equal to 0. Same as this. And it is 0 for x less than 0 or y less than 0. Same as this. So both are same. The joint probability density function fxy of x comma y is same as the product of the marginal probability density functions fx of x into fy of y. Therefore x and y are independent. Probability that x is greater than half. Remember, here in our question there are two random variables x and y. It is a question related to bivariate random variables x and y. So probability that x is greater than half means nothing is mentioned about y. So y varies from minus infinity to plus infinity. So for x greater than half means half to infinity. So probability will be double integral of the joint probability density function fxy of x comma y dy dx from minus infinity to plus infinity, x value from minus infinity to plus infinity, similarly y values from minus infinity to plus infinity. But it is said x is greater than half, so x value you have to ignore below half. Values of x less than half you ignore it. Greater than half means outer integral we have taken with respect to x. So x is from half to infinity. Inner integral with respect to y, and from the definition of fxy of x comma y, for y greater than or equal to 0, x greater than or equal to 0, then only fxy of x comma y will be a into e power minus 2x plus 3y. So y should be considered as greater than or equal to 0. Otherwise for y less than 0, that joint probability density function will be 0. So the whole double integral will be 0. So consider y as greater than or equal to 0 means y is from 0 to infinity. Fxy of x comma y you can substitute with a as 6. Now for inner 6 can be kept outside the double integral sign. Inner integral is with respect to y. So keep this e power minus 2x as it is. Calculate this inner integral first. Integral of e power minus 3y with respect to y, which is same as e power minus 3y by minus 3, difference at the upper limit infinity, lower limit 0. So 6 into integral half to infinity e power minus 2x into this integral will be e power minus 3y by minus 3 at the difference at the upper and lower limit integration with respect to x dx. Now 6 divided by minus 3. Integral from half to infinity e power minus 2x. Difference of this e power minus 3y at infinity and 0 means e power minus infinity will be 0 minus e power 0 will be 1. 0 minus 1 is this minus 1. So now there are two negative signs. So 6 by minus 3 into minus 1 means positive. 6 by 3, 2. Integration of e power minus 2x with respect to x means e power minus 2x by minus 2. Difference at the upper limit infinity, lower limit half. 2 by minus 2 is minus 1 into difference of e power 2x at infinity and half. E power minus infinity means 0. Minus e power minus 2 into half means e power minus 1. So minus of minus will be plus e power minus 1. So this will be the probability that x will be greater than half. And this value of e power minus 1 can be calculated by using the calculator or can be kept as it is. Then the probability that y is less than 1. Y less than 1. Y varies from minus infinity to plus infinity. So probability that y is less than 1 means minus infinity to 1. So x will be from minus infinity to plus infinity. Y will be from minus infinity to 1. Now for y negative, fxy of x comma y is 0. Even for x negative, fxy of x comma y will be 0. So ignore that negative values of x and y. So consider x as 0 to infinity, y as 0 to 1. Then fxy of x comma y is a into a is 6. 6 into e power minus of 2x plus 3y dy dx. 6 can be kept outside the double integral symbol. Integration with respect to y. So first keep this e power minus 2x as it is. Integral from 0 to 1 e power minus 3y dy dx. First calculate the inner integral. Integration of e power minus. Then integral 0 to infinity e power minus 2x. Difference of e power minus 3y at x and 0, which will be e power minus 3x minus e power 0 is asked in the question. But here to prove that x and y are independent, to check whether x and y are independent, we have already calculated the marginal probability density function of x and y, fx of x and fy of y. That you can use in the as the answer for the fourth part. Taking the integral, we have taken y from greater than x less than y. 1. So x is less than y. So here x is less than y. Y from 0 to 1. Y is greater than x. So if you multiply 4x into 1 minus x square into 4y cube, you don't get it as kxy, 8xy. You don't get it as 8xy. That means this product is not equal to joint probability density function. Fx of x into fy of y is not equal to fxy of x comma y. Therefore x and y are not independent.